steep, and then it kind of slows down, and then it goes really, really steep again. Okay, so sometimes your cubic function looks like this. What I want you to do is pull out your calculators, and I want you to put this equation into y1. Okay, and we're going to take a look at this next equation. We're going to put down a table of values so that we can plot it and look at some of the main things about it and describe it. Okay, so head over to your calculators. It's clear what you were doing before. Yeah, the one on the right. You didn't do that. Yeah. So 2x cubed plus 4x squared minus 3x plus 5. Okay, let's assume. We're not just assuming a little bit to line. Actually, let me just check the line. Okay, we're just fixing the equation because we're going to Okay, guys, you should all have a graph in front of you. Right? You have calculators?
Yeah, it's in my car.
Anybody not have a calculator today? Okay. So guys, what I want, I'm hearing a lot of chatter, which probably means that you're not sure what to do. Okay, guys, in the back corner, put it away. Whatever you were doing, you're like chatting. Okay, pull out your notes. Are you graphing this? Have you made a table of contents? Table of values? Okay. Okay, so if you head over to second graph, you'll find your table of values. Okay, actually it's centered out really, really nicely because we can put, like if we go up, right, -4 and -51, that's kind of like off our chart. So I would keep it to -3 and then to +1, okay, because as soon as we get to 2, it goes off of our chart up to 27. Okay. So just on the edge, you can make a table of values. Okay. Okay, and write them in from your calculator. Okay, and then I want you to plot those. So -3, -8, -2, +7, way up here. -1, 6. 0, 1, 1, 4. Okay, so these are the points that we have so far. Okay, one of the things that you will need, okay, so with your calculator, if we just kind of, I'm going to scroll down to the bottom here, okay, it's going to ask for a turning point. How many, like if you look at your calculator, how many turning points does your cubic have? Yeah, it's got a maximum here and a minimum here. So what I want you to do is I want you to find out the coordinates of the max and the min. Okay, so if you go to second trace, right, you can use the minimum. Okay, and then just go to the left and right of your minimum, and you can also use your maximum feature.
Can I see you put in for the y value of the graph? Oh, so you put it
Okay, so we have 2 turning points, and we're figuring out the maximum and the minimum. Well, you need them in your graph. Like you need those. Those are critical points of your graph. Yeah. Okay. Here we go. What am I doing? I'm doing the max first. curve to the right. Okay, so make sure that you guys can do these. Okay, and you can round to the nearest 10. So negative 1.6 and 7.9. Right? And then we're going to do the same thing, second trace, and then do the minimum. And once a little bit to the left. And to the right. Okay, and so that 0.3 and 0.5. I know. Right. So go ahead and plot those as well. Okay, but also one more thing. Actually, let's put them on here. So. Okay, guys, when you're graphing this, okay, you want to include your min-max values. Okay, and you also want to have your x-intercept. You can't pull those off your table of values because they're decimals. Okay, so you have to do what we just did, where we did the minimum and the maximum with second trace. Okay, to get the x-intercept, that's what your calculator calls a 0. So if you go over to second trace, you'll see number 2 is a 0. Okay, and it just wants to know, like, it's asking for a little bit of help. Can you guide it to where the 0 is? Okay, here, put it on my desk. Really?
Yeah.
Like you're like totally looking down at your hand.
What's good? It's not.
Okay, you had your phone out, put it on my desk.
I wasn't even on.
Just then pull it out and put it on my desk. That's fine. Alright, there we go. Okay, our 0 is a negative 6. Alright. Since I'm getting so much chatter, I'm just assuming that you guys know how to do this set. Okay. Okay, so what did you fill out for your leading coefficient?
2.
Awesome. Okay, tell me about the graph. So let's go, what does it do on the right?
Down.
Okay, so it told me that we have a positive leading coefficient. Up on the right. Okay, guys, if it's a positive leading coefficient, it's up on the right always.
Right. We were talking about it's also minimal on the right.
Yeah. But
That's fine.
the end tail.
Yeah, that's
Yeah. So up on the right, and because it's an odd degree, it's down on the left. Okay, when you guys are writing the test and you're like, up on the right, down on the left, you will thank me. Okay? Because like it's in your brain. Down on the left. Okay? And that's because it's an odd degree. So they're opposite. Okay? What is the y-intercept of our graph?
0, 1.
0, 1. Awesome. Guys, if I asked you how many possible x-intercepts are there with a cubic? How many possible x-intercepts?
3.
Okay? It's always is going to be, the maximum number that you can have is the same as the degrees. There could be 3, okay? There could be 2, or there could be 1. Okay, could there ever be 0? No. And odd degrees will always intersect. Okay? But sometimes the questions will say, how many possible x intersects? This one just wants to know the number, and in this case, we just have 1. Okay, and our domain and range. Are there any restrictions on our domain and range? For an odd function, there are no restrictions. Okay, whether it's a linear line or whether it is a cubic. Okay. Right, go ahead and take a look at example 1, the graphs. Okay, I want you to identify which one you would say is most likely the graph of a cubic function. Let's take a look at them. Okay, survey says.
Are we looking at the question? It is B.
When it says B, say it is B. Okay, so what is A called?
What?
Yeah. So this is a parabola. So maybe write this down. Okay, B is your cubic. Because anybody get into like radio wave frequencies? Everybody know what this is called?
A microwave.
Sort of. Right? Guys, we're going to be learning about this in 2 units. This is called a sinusoid.
I was so close.
Okay, it's common. And then this guy here. Okay, this one that starts off really small and then gets really big. Think of like a bacteria in a petri dish and how it like doubles and doubles and doubles and doubles. So this is called exponential. This is our next unit. Okay? We're going to be learning about exponential functions after this one. Yes. Sorry. That's actually a better description for it. It's quadratic. Parabola is it has minimums and maximums. Yeah, I changed it to quadratic. The shape is a parabola, okay, but the function is a quadratic. So we're just being a little bit more accurate. Yes.
On the last question, you know how if it's cubic,
Yes.
it's like down on the left. The question before it was like up on the right or up on the left.
That's because it had a negative coefficient.
So it's just the opposite of
That's what I thought.
okay.
So the next leading coefficient is down on the right.
Okay.
And then because it's an odd degree, then it's opposite to the other. Hey guys, here's one of those diagrams. Okay, we filled these all out for our linear lines and our parabolas. I want you now to take a look at this. This gives you the general form, right? The standard form of a cubic function. And it tells you that A is greater than 0, which means A is positive. So what are we going to draw when our leading coefficient is positive? What's up on the right?
Oh.
Okay, so this is a positive leading coefficient. Okay, D is our y-intercept, exactly. And it's also positive. Okay, so this is our y-intercept, positive. So go ahead and make a positive y-intercept. Okay? Anywhere you want on that y-axis as long as it's positive. Okay, and then just make sure that your cubic function is up on the right, and what's going to do on the left? Down on the left. Okay, so it might look like, it might look like that.
How do you know what you're going to have the turning point? Or
You decide. For this, you decide. Like you could have done this. No, you could have done point of inflection.
nothing to tell us what.
No. Hey, you guys could have done something like Nice. I don't know. Like there's so many things that you can use. Okay. Okay, so lots of options. As long as you're going through a positive y-intercept and you're up on the right, down on the left. Okay, so do the next one.
Negative meaning 20%.
Okay.
Oh, no.
So we're gonna have negative leading coefficient.
Positive y-intercept is 0.
Okay.
It's going to be
And right, so we're down on the right, up on the left. Make for a positive y-intercept. Alright.
An intercept.
the ones you got a 33 on.
Okay, so guys, this next question, they're asking you to do the same thing for a linear function, a quadratic function, and a cubic function. Okay? You need to notice like all the things that you have to be able to describe for these. So this section of this unit, yes, there's a lot of writing. So we're going to go through this, okay, and write out all the things that we need to know about these particular functions. Okay, so this first one, let's identify it. Okay, what degree is A? Yeah. Okay, it's degree 1, which means what kind of function is it? It's linear.
Linear.
Okay, guys, how many possible x-intercepts, okay, in a linear line? 1. Okay, so it says number possible. Guys, it doesn't actually ask you, like, how many does this exact equation have? It just wants how many are possible for this type. So if you were to put this into your calculator, right, that would help you. Just make sure you're reading the question really carefully because it wants possible rather than actual ones. So this is, so we're going to write one possible x-intercept. Okay, the next thing, it wants to know what is the y-intercept. Give me the coordinates, someone.
0, 5.
Yeah.
Oh, yes. Walking goals.
Okay. What is the end behavior? So let's start with, what does it do on the right? Okay, down on the right because we have a negative leading coefficient. Okay, so down on the right, what's it doing on the left? Up on the left because it's an odd degree. Okay. You might also see it described as, okay, if it's up on the right, down on the left, okay, it's doing something like this. Guys, what quadrant, if we read it left to right, what quadrant are we starting in, and what quadrant are we finishing in?
3.
Starting quadrant 2 and leaving quadrant.
We're starting.
Okay, so let's remember how to number our quadrants. So we're starting in quadrant 3.
That's not what it is.
It's a negative. Oh, of course. You guys are way better than me. You should come up and teach. Yes, it is a negative leading coefficient, so it's totally doing that. Okay, so it is, okay, totally going from Q2 to Q4. So what you might notice is the questions in your homework, right, or a question on a quiz might give you, okay, coordinates, like the quadrants, okay, and you have to be able to recognize that, and you just read it from left to right. So we are in quadrant 2 first, and then we end up in quadrant 4. Okay, the final thing that it wants to know, domain and range. Are there any restrictions for odd degree? For a linear line? No, there's no restrictions. then our range y such that y belongs to real numbers. Okay, number of, again, possible turning points. Any possible turning points in our linear function? 0. Okay, 0 turning points.
So stuck.
Okay, if you're feeling good about this, okay, start the next one. Okay, you have something written down.
I was answering all that. I got this. I got this from August.
Okay, so what should we get? Okay. Okay, this is degree 2. What do we call our degree 2 functions? Quadratic.
How to get it out
Okay. How many possible x-intercepts?
2.
Yeah, or?
1.
Yeah. Okay. 2, 1, or 0 possible. Yeah. So wants to know how many possible ones there are. We could have 2, 1, or 0. Okay, what is this x-intercept here? Awesome. 0.6. Okay, describe it for me. What's doing on the right? Yeah, it has a positive leading coefficient, so we're up on the right. Okay, what are we doing on the left with the even degree? Yeah. When it's even, yeah. Up on the left. Okay. Do we have restrictions with the parabola? We sure do. Our domain, we don't. X such that x belongs to real numbers. Okay, but our range. Okay, guys, our range is tied to, okay, a min or a max point. So you actually have to go to your calculator and figure out, okay, what your maximum point is. Okay, so down here we're going to just do what is our max. Y equals x squared plus 2x 6. Second trace minimum. Yeah, -7, 0. Okay, so our y value is such that it has to be, let's take a look at it, greater than or less than our minimum. Greater than. Okay, greater than or equal to 7. After that, y belongs to real numbers. Oops. 7. Why do I have? There we go. -7. Oh, I see what you're saying here. This one doesn't do it. Yeah, because it's like when it's like a pixel off. So -1. Yeah. Okay, how many turning points does a quadratic have?
Oh.
Yes, 1. Alright, final one, guys. Okay, this is a degree 3, it's cubic. possible x-intercepts? There could be 3. Could be 2.
Could be 1.
Could be 1. Could there be 0? No. So. Okay, what's the y-intercept of this particular function?
Oh, excuse me.
Yes.
What? Oh, this is max.
Yes. Yeah, my handwriting's a little sloppy. Okay. Awesome. Okay. 0, -1 for your y-intercept. Steve, talk to me about the tail. Sometimes you might see end behavior, or it'll ask you about the tail. Okay, that's the end behavior. So what's it doing? Yeah, it's doing it. Okay, possibility coefficient, totally up on the right.
Does the negative on the x squared mean that it's going to be down on the left? That has nothing to do with it.
That has nothing to do with it.
But
Yeah. The reason why it's on the left is simply because it's an odd degree. And it's always opposite. Yeah. We're going to try and see if there's a pattern or something going on there. Wait, that's not that. So this one, because this was a negative leading coefficient, it's down on the right. Down on the right. And then it's opposite because it's a square. So this one had a positive leading coefficient, so it's up on the right, and then it's opposite on the other side. Okay. Guys, are there any restrictions on an odd degree? That's like not away. Like under your desk, something. Okay, x such that x belongs to real numbers. Our range. Y such that y belongs to real numbers. Okay, possible turning points. Okay, how many possible turning points with the cubic function? Okay, there's 2 or none. A point of inflection is not a turning point. Okay, so it's either 2 or 0 turning points.
Going the other way.
So just maybe make yourself a little note there. Okay. Point of inflection is not a turning point. It's that little jog. Like that. Like where it just kind of goes. Yeah, just that. That's my word for end. Yeah. Versus changing direction. So we were going up, now we're going down. Going down, now we're going up. Those are changing direction. This feels like we're going down, and then we're still going down. Yeah. Awesome. Okay. Slow then. Okay. Here's what we're gonna do. Yes. Yes. Okay. I'm gonna give you guys like a little bit of time to do these questions. Okay, there's only 4 of them, and then we got to move on to linear regression.
Can we do them as homework? And then people that do them get good.
Okay, let's see what these questions are. Okay, let's see what they are. You can do them on your own. They're asking you questions, and they're going to give you either data or an equation, and they want you to be able to make predictions based on the data and the equation. Now, sometimes when they give you data, we have to come up with the equation that best models what's happening. Okay, that's what regression is. Regression is taking data points and coming up with an equation. So a few definitions that we need to know. So take a look at the diagram in your notes, and you'll see like a whole bunch of dots. So this would be like real world data, where they have, in this case, they're looking at the height and the length of something. And they've actually like taken measurements, and they said, okay, for this one, when it was a height of 4 feet, it had a length of 8 feet. I don't know exactly, if they're like doing cut wood or something like that. Okay, but what happens is they plot the dots, and then mathematicians, okay, and you guys are young mathematicians, okay, try to describe a line that if you were to draw the line, it would kind of like land in the middle of the dots, right? Where there's a little on the top, there's a little on the bottom, but you're trying to do something called the line of best fit. So when the information that you have is real world information, it doesn't exactly follow all of the theoretical work that our equations have. So we need to kind of give a best guesstimate for some of that. So that's what a line of best fit is. Okay, a regression function is a line or curve, because sometimes the things that we're talking about might, like if you're talking about the temperature in the summertime, right, the temperature goes up for a couple months and then it kind of heads back down, which sort of looks a little bit like a parabola. Okay, so they're able to say a line or curve of best fit, okay, developed through your statistical analysis of data. Okay, your graphing calculator has some pretty cool features that allows you guys to do this. So we're going to, okay, you need to pull out your calculator, you need to be doing these because we need to like get familiar with where all the buttons are that we have to push in order to get our equations of the equation of a line, okay, or the curve of best fit. Okay? You need to know two big definitions: interpolation and extrapolation. Okay? Interpolation and extrapolation, excuse me. Okay, so the inter means that we're looking at data that's like inside your graph, right? Inside your window. No, I'm teaching a lesson, have a seat, okay, and pay attention and wait till I take a break. Okay? Extrapolation is based on outside information. Okay? Yeah. Okay, not too hard. Okay, guys. This is like, we're like, maybe flag this page because we're going to kind of be going back here. These are the instructions on how to, okay, enter things into our calculator, how to make lists, and how to turn everything on. Okay, so first what we're going to, I'll come back to this. The first thing that we're going to do, because this is a one-time only thing, we're going to turn on, okay, a feature that's called our R-squared value. Okay, this only needs to be done once, and then it's done. Okay, so only has to be done once. Wow, done once. So follow the instructions. I want you to hit second 0 on your calculator. So second 0, okay, is a catalog. And you're going to scroll all the way down, okay, until you hit diagnostic on. So go through the A, B, C's, and D's. Okay. There we go. Diagnostic off, diagnostic on. So you want to scroll up to diagnostic on. Okay, you guys are following along, right? Okay. Oh, okay, make sure that you're not in this thing. I was in the wrong mode, sorry. Okay, clear. Here we go. Seconds there. I thought to do it all the time. I know. Okay, hopefully you were not in your graph section when you did it. And it worked just fine. Okay, diagnostic on. Here we go. There. You just hit enter, and then it says done. Okay, once your diagnostic is on, then we're good.
How'd you get this one?
I might have a slightly older calculator on the screen. Okay, so if it doesn't say done, it's probably okay. Okay, so guys, the reason that we did this, okay, because your question really should be, well, what is this R-squared value? Okay, an R-squared value, let's say that I had this scatter plot that looked like this. Okay, and then I drew my line of best fit. Okay, I would probably say that like maybe it hits 60% of the dots, like they're really widely spread out. Okay, so this would be like a best fit, let's say like 0.6. So 60% of the data, 60% 90% of data would kind of follow this line. Okay, however, when we tell the calculator to turn diagnostics on, we're looking for the R-squared value that's as close to the number 1 as we can. Because what that means is, okay, we're basically, okay, we want it to be, like this is an R-squared value, okay, of 1. Or actually like 0.99. Okay, that would be really good. So if you had a bunch of data and they asked you to do a line of best fit, but you weren't sure if the data was linear or if the data was quadratic, you would, when you do your regression, you would look at the value of this R squared, and whichever one was closer to 1, okay, that's the one that you would choose. So if the linear R squared value was closer to 1, you say, oh, I can model this information with a linear. Okay? So what we're going to do is, okay, we're going to actually do some data. We're going to come back to here. Okay, these are our steps. Our step 1 is always going to be entering the information into lists. And I'm pretty sure you've done lists before, but I'll kind of jog your memory on that. Maybe it's been a while. Okay, number 2, so step 2, okay, is identifying the type of polynomial that we're going to be using. And then, okay, that's your determining your regression equation. And then step 3, okay, is graphing the regression equation. Okay, and I'm just going to put a little note here which will make sense once we do our example. Okay, guys, we want, okay, all, okay, the decimal places to go into our calculator, to go into the graph, and this is how. Okay, these steps right here show us how to take all the information and put it into our graph. Okay, so I've kind of given you the rundown. This is what it looks like. Okay, so let's actually turn the page, and we're going to see our first example with some data. Okay, and then we'll come back here and we'll do all the steps together. So here's our data. Okay, notice first of all that this is just like a T table, but it's just sideways. Right? Usually we're used to like our table of contents, and we have the X on the left and the Y on the right. Okay, guys, this is just your X here, and your Y's on the bottom. Okay. So the first thing that we're going to do is we need to enter all of this data into your calculator. Okay. So look at the previous page. We're going to enter data into lists. So we're going to clear our lists, just in case you have something like from last year where you're just fooling around on your calculator. So go to your calculator, and you're going to go second plus, okay, if you hit number 4, it says clear all lists. Second plus 4, clear lists. Done. Awesome. Okay, next we're going to, okay, we're going to hit stat. Okay, stat, and then right where it is, edit. So just hit enter. Here's your lists. Okay, make sure you hear it. Make sure you get a button that says stat. Yeah. Okay, so stat, then enter. Everybody there? Okay, all right. So now what you want to do is you want to just arrow over to your list 1. Okay, and in your notes, okay, list 1 is all your X values. You're going to do 1996, enter. 1998, enter. 1999, enter. Then you have to hit every data point. So 1996, enter. Okay, 1998, 99, enter. 2002, 2003, 2004, 2007, 2008, you've done all of your X's, just arrow over, okay, and fill out list 2. Those are all your Y values. Okay, so those are the decimal ones. So 78.04. Okay, 79.14. 81.16. 82.60. 3.72. 84.22. 86.77. 7.2. Now the important thing here is, okay, when you're done, your table should be even. You should have the same number of elements in list 1 as you do in list 2. If you're off by 1, it just means that you missed 1. And so you have to go back and find your mistake and retype your numbers in so that both of your lists are even. Okay? So we have list 1 and list 2 are done. Okay? Then what we're going to do, okay? So you can exit the list by pressing second mode, right? That quits your list. So from here, second mode, we're back to our regular screen. Okay? Then what we're going to do is we're going to press stat. Okay, if you're following along, we're on step 2. Okay, determine the regression equation. So you hit stat and you arrow over one to your calc. Okay, the question that we're doing, okay, we're looking at farthest distance traveled by bicycle in an hour. Okay, and it says determine the linear regression. So they're telling us what kind of regression. So we just go down to number 4, linear. Notice we have linear, quadratic, and cubic. Those are the 3 regression types that we're going to be doing. Okay, linear, quadratic, cubic. So this one, it tells us we're going to be doing linear. So you can either arrow down to 4 or just hit 4. Okay. Now your screen might look a little bit different. Okay, but the idea is still the same. Okay, you don't have to enter anything here. You just keep hitting enter. Okay, until it goes through all this little menu things. Mine says calculate. I hit enter, and it gives me this. Okay, so you have a dimension mismatch, which means that, okay, yours, that, stat. Okay, so you have a string of wood, yeah. So you just go down there. That was probably just that by accident. We're just going to clear that one. Let's continue. Step 2. There we go. I just did it. Okay, so now do that one. So stat. Okay, so all of you should have this nice summary. Okay, so here's the thing. In your notes, okay, determine the linear regression equation. I want you to, okay, write down the summary. Okay, round to the nearest 100. Okay, guys, this is for making sure we're talking about the same equation. However, okay, we're not actually going to use this equation other than as a summary. And I'll explain what we're going to use instead. Okay, so if we go back to our summary, A is equal to 0.858, and I said to the nearest 100, so that means 2 decimal places, 0.86. Okay, so this is what they gave us, a linear regression. Here's the value, 0.86. We still write our X. Okay, and then our B value is negative 1,635.73. So minus 1635.73. Okay. Now the next thing that we're going to do is we're going to put the equation. This is called the regression equation. Okay. when we're graphing and answering questions, we are going to be using the answering questions. Okay? We're going to be using something called the regression equation. That is this thing right here with all those beautiful decimal points. We're not going to do any rounding on this. So what we're going to do is, in your notes, okay, it walks you through. We are now on, okay, graph the regression equation. So we have to send this equation to y1. Okay, so go ahead and press y1. Okay, so we're here, and now we're going to hit y1. Clear whatever was there before. If there was anything in your y1 equals, clear it. Okay, and you're going to put in that regression equation. Here's how you do it. Okay, your notes walks you through it. Okay, hit. You have a button called vars. It stands for variables. Okay, so vars, and then you're going to hit statistics, and then you're going to go 1 over. So I'll do it with you. Okay, vars is right here beside my clear. Vars. Okay, you're going to do number 5, statistics. You're going to arrow over twice to equation, EQ at the top. You should be following along, guys, so that you can do regressions. Like you're going to have to build muscle memory and get really fast at this stuff. So practicing now will really aid you in this process. Okay, so when you get to, does everybody get to bars? Okay, you're good with that? Okay, you arrow it over to equation, you have your regression equation, hit enter. Okay guys, what it did is it just pasted our linear regression with all those beautiful decimals into y equals. Okay, so you don't have to type any of that out, and you never should. You have to use, okay, vars, stats, arrow over to equation, and put in the regression equation. Okay, now, okay, now go ahead and hit graph. Okay, does anybody see anything? No. Okay, why don't we see anything? Yeah.
Because it's not on the scale that we have.
Okay, guys, look at your data. We're talking about years from 1996 until 2009. And our little window is our standard window at like 10, 10, negative 10, right? So if you hit graph and you don't see anything, it's just because you haven't adjusted your windows yet. So you have to look at your data, and that will help you set your windows. So your X, really our data goes from like 1996. So why don't we like just go down, like be generous, like let's say like 1980, just to be a little bit generous. So if we do window, okay, let's say our minimum is 1980, and our max on here is 2009, but they're probably going to want us to like project into the future. Okay, so like why don't we pick like 2020 for our Y max? You can always come back and adjust these if it's a little too generous. Okay. Your Y min, okay, so let's look at, in our notes, let's look at our data again. Okay, our Y min goes from 0.78 up to 90. Okay, so maybe we go like, again, drop it down. Let's go from like 70, and maybe we do up to 100. Okay, 70 to 100. Okay, so I'm going to go from 70 to 100. And then hit graph. Hey, look at that. We've got this beautiful straight line. Okay? So make sure that you've got this awesome straight line. So it shouldn't have surprised us that it was straight because we did a linear regression. You would anticipate having a straight line. Okay? Once you put in your windows, then we can use that. Yeah, memorize it. Okay, we're going to do so much of it that you are going to have it memorized. Okay, so if you need to like write it out a couple of times, you just write it back. So here's what happens. Okay, all of that work you put in your data points. We figured out, okay, this is kind of like a summary. Okay, but when we answer the questions, okay, so for some of you, especially if you took 20-1 last year, a lot of you are used to substituting and solving it algebraically. Okay, we're just going to be using the graphing calculator, okay, because it has, if we substitute it into here, we're not going to have exactly the same answer as our neighbor, simply because there's rounding that happened. Okay, but if we use the features of the calculator, it has all the decimal places, so that's what we're going to do. So the first question says, interpolate. You can remind me what interpolate, where am I looking for data? Within the graph. So that means, do I need to change my window settings? No, because I should be able to see whatever they're asking. Interpolate the world record distance for the year 2006. So if you look up here, there's a gap, right? 2004 to 2007. There was no 2006, but since we have a regression formula, we can figure out what it is. So that means that our year was our x value. So that means our x that we're looking for is 2006. Okay, guys, how do you figure out what the matching value when x is equal to 2006? How do you figure that out? Okay, if you hit trace, trace is where you tell it the x value. If you type in 2006 and hit enter, it will tell you the value of the furthest distance traveled by a bicycle in 2006. Okay, 86 point, it says round to the nearest 100, so 86.38. Okay, so y is equal to 86.38. Okay, but it asks a question. It says the world, so we have to answer in a sentence with units. Okay, the world record distance in 2006 is 86.38 kilometers. Okay, that's it for this slide. So interpolation, you're going to be using the trace feature. So if you need to write that down in the margin so you know what buttons to press, okay, because this is the way that I'm going to show you. I'm just going to say x is equal to 2006, and you need to know that you're using trace in order to figure out the y. Okay, determine the first year. Here's the next question. Determine the first year that the distance reached over 85. Is the distance my x or my y? Y. Okay, so when you see this, you're going to say this is my, this is what my y equals. Okay, so just a sec. Okay, so this is y. Okay, now I already have something in y1. So what I'm going to do is I'm going to say y2 is equal to 85. So go over to your calculator, okay, and you're going to hit the y equals button, and you're going to put in 85 here. Okay, what's going to happen is it's going to draw a horizontal line at 85, okay, and our line is going to intersect with it. And so what we want to do is when we see this, okay, so this was our 85, and we want to know when, in what year, okay, did we hit over 85? Okay, so you're going to use your intersect feature. Okay, so second trace, intersect. Okay, and when there's only two graphs, okay, you can just hit enter, enter, enter. Okay, it's going to find the first graph, it's going to find the second graph, you never have to put in a guess, and it's going to zero in on the point of intersection. So it says that, okay, if you're interested in 85, it happened in 2004. Okay? So here, so just make sure, again, when you're graphing interpolation, you should already be able to see it in your window. If it asks for extrapolation, you might just have to change your window settings because you have to be able to see where it actually intersects. If you can't see the intersection, your calculator can't find it for you if it's off the screen. Okay, you have to be able to see it for your calculator to give you the answer there. Okay, so here, x is equal to 2004.39. Okay, technically it had a decimal. However, it says determine the first year, the distance reached over 85. We would round that down to the nearest year. Okay? So we would say the first year, the distance reached, okay, over 85 kilometers. That's 2000. Okay. So maybe make a little note in the side. Second trace intersection. Okay. Okay. Are you guys ready to try this on your own? Not yet. Okay. It's gonna take a few things. Okay, let us. Okay, I'll let you finish writing that down. Okay. So that was our introduction to regressions. Okay, we're going to pick up tomorrow. We're going to finish up with linear regression, and we're going to continue on into quadratic, cubic, that sort of thing.